So we're going to review solving systems of equations. And just as a brief review, what is the systems of equations? It's just any equations. And I'm going to start with my first one. I have y is equal to 5x minus 21. The graph of that, I'm going to graph that one in red, roughly looks like this. Down here somewhere at negative 21 and has a slope of 5. It's going to roughly, very roughly come like this. The next one is 2x plus 4y is equal to 4. And that's going to give me intercepts here at 2 and 4, and it's going to come down and look something like this. Now this is just a rough graph. You can spend more time graphing them if you wish and finding the exact solution, but what's really important here is I want to know where these two lines meet. All right, so the way I'm going to do that algebraically is I'm going to go ahead and start with this first equation that I have, my 2x plus 4y is equal to 4, and I'm going to take my first equation, which is y is equal to 5x minus 21, and wherever I have y, I'm going to put this whole thing in. So what I mean by that is I'm going to take this, it's going to be 2x plus 4. This is my y value is equal to 4. I know from my equation over here that y is equal to 5x minus 21. So that's what I go ahead and put inside that parenthesis. Let me just fix that. I don't like the way that looks. That's a 21. All right. So now I want to go ahead and solve this for x. So now I am left with, I need to distribute the 4 to both pieces on the inside of that parenthesis. So that gives me 4 times 5x is plus 20x. 4 times negative 21 gives me a negative 48 is all equal to 4. I combine my like terms and I have 22 x minus 84 is equal to 4. I add 84 to both sides. Now I have 22x is equal to 88. Divide both sides by 22 and I get x is equal to 4. And again, what does that mean? It tells me that this point over here, did a pretty good job of estimating it, has an x value of 4, which is exactly what I want because I'm saying that this point right here, I want to know it as an order pair, so my x value for that point is 4. Now, how do I find my y? I can plug it back into either equation, but I'm going to plug it into this first equation. Again, x is 4, that's my input, so I'm plugging it into there. So to find my y value is just y is equal to 5 times 4 minus 21, or 20 minus 21 gives me my y value of negative 1. And again, it's really important we always enter these as, and write the answer as a point. All right, so we want to solve the systems of equations, and we just reviewed what it looks like, so I'm not going to graph this. But what I want everyone to notice it is, in this case, you have 2 and negative 5 here. And we can multiply it, but if I go ahead, and it will work, but if I go ahead and look over the y's are what I call opposite coefficients, right? This is a negative 1 and this is a positive 1. So if we start with the y values here, it really makes life easy for us, because if I add these two equations together, I end up getting 2x minus 5, which just leaves me with negative 3x. Then negative y plus y is 0y, so that's completely gone. And the last one is 9 minus 24, which leaves me with 3x is equal to a negative 15. divide both sides by 3, and I get x is equal to 5. So that's the first part of my ordered pair answer. Now, I can do two different things. I can do the same thing again and get rid of x's, or I can substitute. And I'm going to substitute into my first equation. And by my equation 1, I'm calling this 1 because it's my first equation. I'm going to call that equation 1. And a lot of times we like to label them as E1. So if I'm going to plug my x value back into there, I'm going to have 2 times 5 minus y is equal to 9. 10 minus y is equal to 9. Subtract 10 from both sides. Negative y is equal to negative 1, but that's not the answer. You got to divide both by a negative 1, and I'm left with y is equal to 1. So that goes up into my ordered pair as my solution, and that would be the solution point, or where those two lines would meet at 5, 1. This will be the last one in our review. So as I'm inspecting the coefficients, the 4 and the 5 are not, and they are not multiples of each other. And they're both the same negative. So I don't want to use y first. This time I'm looking at the x's. This x is a negative 8. The bottom one is a positive 4. So it would make it very convenient to multiply this whole equation through by 2. And when I do that, I'm just write both of them over. I'm going to rewrite my first equation, which is negative 8x minus 4y is equal to 56. And when I multiply the second equation through by that negative 2, again, make sure you multiply it times all of the pieces. That leaves me with a positive 8x minus 10y, and 0 times 2 is just 0. But what we're looking for is this idea of opposite coefficients. So now, if I can go through and add these equations together, the 8x's become 0, and I'm left with negative 14y is equal to 56. I divide both sides by a negative 14, and I get y is equal to negative 4. So that is part of my solution set. I need that. That's one part. But remember, a solution set needs to be an ordered pair, my x value and y value. So that is going to be the first part, but I'm not done yet, right? Okay, now, how do I find the x value? I can go back into either of the two original equations. It doesn't matter which one I use. I'm going to just take my 4x minus 5y is equal to 0. I like this one because it's 0. I'm going to take that y is equal to negative 4 and plug it in. That leaves me with 4x minus 5 times negative 4 is equal to 0, or 4x minus 20 is equal to 0. I move the 20 to the other side, and I have, was going too quickly, a negative 5 times a negative 4. That gives me a positive. Hope you caught that on your own first. I'm going to take the negative 20 and move it to the other side. When I do that, that gives me a 4x is equal to negative 20. Divide both sides by a positive 4, and my x value is negative 5. So my final answer, again, must always be in this ordered pair of x and y.